Well, we're going to be discussing absolute value functions and their graphs. So by the time we're done with this lesson, you should be able to graph absolute value functions. So let's do a little warm-up. Let's start with practicing and remembering how to solve absolute value equations. So pause the video for a moment and work the problems, then come back and check your answer. Okay, did you remember to subtract 2 from both sides? Then set it up for the positive and the negative. So x could be equal to 8, or x could be equal to -2. How about this one? Did you start by multiplying both sides by 3? Then set it up for the positive and negative. So x is either 21/5 or x is equal to -3. Very good. All right, the key concept, we're going to graph the absolute value function f of x is equal to the absolute value of x. So we're going to graph a parent function. We'll start with a table of values using 0, 1, -1, 2, and -2. We simply substitute in for x and we find our values for y. The key concepts we're going to learn about today is the axis of symmetry. That is the line that divides a figure into two parts that are mirror images. And then there's the vertex. That's the point where the function reaches a maximum or a minimum value. So let's look at the graph of the absolute value function. Y is equal to the absolute value of x minus 4. Okay, so first of all, let's look at the parent function. Y is equal to the absolute value of x. So if you want to enter that in your function editor, in your graphing calculator, that would be awesome. And notice that we're going down 4. Okay, the -4 is outside the grouping symbol. So we're going to take this function and move it down 4 units. You want to make a note of these key concepts. The transformations of y is equal to the absolute value of x. Very similar to what we've learned before on linear equations. So vertical translations will move your k units up or down. Horizontal, your h will be right or left. And remember, it's opposite what you think when it's inside the grouping symbol, opposite of what you normally think. A vertical stretch or compression, it'll be a stretched if it's greater than 1. If a is greater than 1, it'll be compressed if a is between 0 and 1. And then there's a reflection across the x-axis if y is equal to negative on the outside of the grouping symbol of the absolute value of x. So let's graph each absolute value function. First of all, we're going to graph the parent function. Y is equal to the absolute value of x. What's going to happen here and here? Well, it's going to go up 3, left 2, is it not? What about this one? Let's again graph the absolute value of our parent function. And we have a dilation of 1/2. Okay, very good. The general form of the absolute value function, where y is equal to a times the absolute value of x minus h plus k, the dilation factor is the a. The vertex is hk. Now, remember this formula says x minus h. So if you see an x minus 1, that means it's going to be, our h is positive 1. If you see x plus 1, then our h would be -1. Okay? So hk is very similar to our xy coordinate. The stretch compression factor is very similar to our slope. And then the axis of symmetry, this is the equation for the axis of symmetry. X is equal to whatever your h is, whatever you get here. So without graphing, identify the vertex, axis of symmetry, and transformations of this function from the parent function. F of x is equal to the absolute value of x. Okay, so we know we're going up 4, vertical shift up 4 units, horizontal shift is going to go right 1 unit. It's going to reflect across the x-axis because of the negative on the outside. It's going to stretch by 3 units. The axis of symmetry is x is equal to a +1 because this is x minus 1 and the vertex is 1, 4. Okay, our last example, we're to write the absolute value equation for the given graph. Now they haven't graphed our parent functions, so you might want to imagine that in your head, or you can put it in your graphing calculator and see what happens. Play with this a little bit to see what your formula, your equation is going to be. Okay, good. Do you see it went up 1, it went right 2, and look at the slope, 1 over 4. Very good. You guys are ready to begin your assignment. Excellent job.